So we are again looking at Hcverma solutions on rotational mechanics. So here I am taking up problem number 34 on page number 197. It's exercise problem from rotational mechanics. Let me draw the figure for you. It is there in the book, but let us draw the figure. This is the ceiling here. The ceiling. Here there is a pulley, and over here we have another pulley. They are attached by a string. And a mass of 2 kg is hung. This pulley is massless, whereas this pulley has a moment of inertia of 0.2 in SI units and its radius is 0.1. We are supposed to find the acceleration of this block. So I hope we have understood the problem here. We are supposed to find the acceleration of this block. Now please note, if the pulley is massless, then tension in two parts of the string will be same. But suppose this pulley was having some mass and moment of inertia, then tension in these two parts will be different. Here this is not a case. Here if tension here is T, tension here will also be T. But if there was another string attached to this particular rod, since this pulley is having a mass, suppose there was another string, the tension would not remain T here. The tension will be different than this. So please note this difference. Of course, we are not concerned with that right now. We will solve it in some other example. So now let us draw the free body diagram of this block, pulley, and we will see. Let us consider this 2 kg mass now. The 2 kg mass of course will be sliding down with an acceleration A. So what are the things acting on the 2 kg mass? The tension T is acting in the upward direction. The weight 2 into G is acting in the downward direction. As the block is going down, the net downward force is 2G minus T, and that is 2A. That gives me the tension T as 2G minus 2. So this is the tension in the rod. This tension in the rod is going to produce a torque. This tension in the rod, tension is always towards the support. So this tension will produce a torque in this particular pulley. So let us find out the acceleration aspects of this situation. T is 2G minus 2A. Please keep it in mind. I'll write it here. Now let us find out the torque and all. The torque produced will be T into radius, and that is going to be equal to I into alpha. So tension is 2G minus 2A. Radius is 0.1. I is given as 0.2 and alpha is A upon R. Again this R is 0.1. So what do you have here is This 2 into 0.1 is 0.2. 0.2 will cancel, and I think this will go up. It will be 10a. So g minus a will be 10a. So a will be g upon 11. That is, please just check out what is the answer. 9.8 upon 11. And the answer is 0.89. A fairly simple problem where we are supposed to find a torque and use A equal to R alpha. You can always use A equal to R alpha in case of purely rotational motions. There is no skidding, sliding, anything. It's a simple problem. In the next problem, they have made it complicated. In the next problem, they have given mass and moment of inertia to this pulley also. And then we are supposed to find tension. So let us do that aspect. Now let us do problem number 35, which is immediately next sum. See the modifications that they have made in this next sum. In addition to this current setup, this pulley, smaller pulley, has a radius of 5 cm and it has a moment of inertia of 0.1. Now we are supposed to find the tensions. Now please note, tensions will be different. Now this will be T1 and this will be T2. So here T1 will be 2g minus 2a. The FBD of this particular part will not change. T1 will be 2g minus 2a. And we will find T2. T2 we can find by the same logic. T2 into radius of this pulley is 0.1. I alpha, I is 0.2 and alpha is A upon R. So that gives me T2 as, how much it will be? 2 upon 0.1, it will be 28. It is correct. 2 upon 0.1, 20. Okay. Now I am going to consider only the smaller pulley. This pulley I am going to consider now, and we are going to find out the value of acceleration. So let us consider only the smaller pulley. I will remove the rest of the figure. It was 20, sorry. So now we have a small pulley. The tension is always away from the body, please remember that. So T1 and T2 are like this. So the torques produced by the two will be different in the different directions, isn't it? So please note that as the pulley is turning in this direction, as the block is moving down, we will take clockwise torque as this is anti-clockwise. So anti-clockwise torque will be positive. And clockwise torque will be negative. The total torque will be therefore T1 into R minus T2 into R. And that is equal to I alpha. Very simple relation. What is T1? 2g minus 2a. T2 was 20a. Radius is given 0.05. I is given 0.1. Alpha is a upon r, and r is again 0.05. So now we have to do this calculation here. So 2g minus 22a is equal to 40. So I have 62a is equal to 2g, and that gives you a as 2 into 9.8 on 62. It's 0.32 approximately. And what is T2 asking us? T2 is 20. It is 20 into 0.32, and that is 6.4 approximately. So the answer is around 6.4, 6.3 newtons. So in this way we calculate. Please note that when the pulley has mass, the two tensions will be different. Thank you.